Solving exponential equations might seem tricky at first, but actually once you get the hang of it, it's really not that bad. So let me show you what we mean by an exponential equation first. I've got an example problem here that says determine the value of x. And then you can see we've got an equal sign in the middle of two different values. And this is called an exponential equation because you can see we have a variable up in the exponent part. So we have to solve for x, but how do we get at it because it's way up in the exponent part of this equation? Well, let me show you some steps. This is the real secret to solving exponential equations, creating a matching set of bases. Now, what do I mean by matching bases? Well, this side has a 5 for a base, and this side has a 25 for a base. Now, there's got to be a way that I can have both bases look the same. It'd be nice if they were both 5, for example. Then we could solve for x quite simply, and I'll show you that in step 2. But how do I take 1 over 25 and turn that into a 5 so that the right side base matches the left side base? Well, let me think of it this way. I'm just going to write out the left side of the equation again. Now, 1 over 25. How can I change 25 so that it's got a base of 5? Well, it's going to be 5 squared. 5 squared makes 25. Now we're getting closer because I have a 5 here and a 5 here, but this 5's down on the bottom, and I don't like that. I'd like to bring it up to the top. So one of the rules of exponents will let me do that. I need to make this a negative exponent. So my next line is going to look like this. The left side stays the same, but to flip this base, I have to make my exponent negative. There we go. Now I have a 5 on the right side and a 5 on the left side. Now we can move on to step 2 where we actually solve for x. In step 2, we're going to set the two exponents equal to each other. Now, since the bases match, these exponents must match as well. So we can show that with some algebra. We can say the exponent on the left, which is x plus 2, must match the exponent on the right. There we go. And now it's just a standard algebra equation. We have to isolate for x. Now, since there's a plus 2 on this side, I'm going to move it to the other side and make it a negative 2. So I'll have x equals negative 2, and then I have another negative 2. Or in other words, x must be equal to negative 4. And that's my final answer. Okay, so try to remember the real trick, and it's going to involve a little bit of practice, is this first step here, creating a matching set of bases, where if you have a 5 on one side, I wanted to create a 5 on the other side. And I had to look at this 25 and think, well, how can I make that a 5? Well, I know 5 squared would make 25, but then I want it up at the top, so I just make that exponent negative. And then I set the two exponents equal to each other and solve for the missing variable. All right, having shown you some steps, let's get you to practice a problem that's really similar to the one I just showed you on the left. Let's see if you can determine the value of x for this equation. Try that out on your own, on paper, and I'll post a solution when you're ready. So, how did you do? We get an answer of x equals 1 for your problem. And just to review the steps, we first had to start creating 3's as the bases on the left side and the right side. So to do that, I ended up having 3 to the exponent negative 3. So hopefully you got that. Once you have the bases matching, it's just a matter of setting the two exponents equal to each other and then isolating for x. Eventually we divide both sides by 2 to get x by itself, which means x equals 1.